Another element or characteristic that we could look at in a function or a relation is the domain and the range. The domain is going to be expressed by the input, the independent, the x values. The range is going to be expressed by the y values, the output, the dependent variables. Okay, so for us, we're going to look at domain and range in a few ways. If we have ordered pairs, that's super easy. All we're going to do is we're going to list the x's if it's the domain, list the y's if it's the range. So I didn't include an example here, but I'll go ahead and write one. So let's say, for example, we had the set 3, 2, 5, 9, and negative 1, 8. If I wanted to find the domain, and sometimes we'll just use a capital D colon to represent domain. So I would just list all of the x values that we see. So it's going to be the list of the numbers 3, 5, and negative 1. You can put them in number order, you don't have to. Then to find the range, I would just simply list all of the y values. So I'm going to have 2, 9, and 8. All right, so like I said, I didn't include an example because it should be pretty straightforward coming from an ordered pair. Now, when we get into finding it from a graph, it gets a little bit more tricky. So I've included some examples here. Let's kind of go through them. So when we look to find the domain is any possible x value. So when I look at this graph, the most common mistake people make is thinking that, oh, it has to be on the x-axis. So we've got some examples where they are and some examples where they're not. So it doesn't have to be where's the graph on the x-axis. It just has to say, or it just has to describe what the possible x values could be. So the furthest point to the left and then the furthest point to the right. Okay, so let's look at that in this first example. If I scan this graph, I go all the way over to the left. The furthest left point that I see is right here at negative 4. So I'm going to use a negative 4 there. Then as I scan this graph to the right, the furthest to the right I could go is at 4. Now I can write this in two different notations. We can write this in interval notation, where that's going to have a comma and either a bracket or a parenthesis. Or I could write it as an inequality, which it's going to have the letter x in the middle because it's domain, we're talking about x's, and it's going to have an inequality symbol. So let's review those symbols. Since I can actually put a point and I am including those values, negative 4 and 4, I would use a bracket. Remember we said bracket is when it's equal. And as the inequality, I would include the equal sign. So both of those ways are how I could write the domain for that function. Okay, we're going to look at the second graph here. We're going to go through the domain for all of them first. So the second graph, again, as I scan to the left, I see, okay, here's that, wait a second, I see an arrow. So an arrow means that it's going to eventually go on and on and on and on and on forever. So as I'm pointing to the left, think about on a number line, the left is representing a negative number, so it's going to represent negative infinity. And then as I scan this graph to the right, the furthest that I see is, oh, I see another arrow. So that's now going to go off to positive infinity, right? Now, if I'm using brackets and parentheses for an interval notation, remember, parentheses always because I can never actually be infinity. Okay. If I was going to write this as an interval, I would include my x because it's the domain, but I would not have an equal sign there. Another way to say this is to say all real numbers, because it's literally including every number from negative infinity to positive infinity. Okay, so let's look at this last example to find the domain. As I scan this graph to the left, I would stop here at negative 2. All right, and then as I scan this graph to the right, I would stop here at 4. So you see on this one here, I'm not going to stop at 2 just because that's the last time it crosses the x. I'm going to scan the entire graph. I go to the furthest point to the right and then find out what that x value is. So it's actually going to stop at 4. Since I have those closed dots on each of these, I would use a bracket. And then if I wanted an inequality, I'd put x in the middle. Since I have a bracket, I would include the equal sign underneath. So that would be the domain for each of these. Okay, so I'm going to clean this up for just a second so we can now do our range here. So let me get this off there. All right. So now let's talk about the range of our graph. So we're going to do the same idea that we did for domain, except instead of looking left to right, I'm going to look to the bottom or the lowest point to the highest point. Okay, so looking at this first value, or excuse me, this first graph, I'm going to find the lowest point. So as I look all the way to the bottom, the lowest point on this graph is going to be at -3. The highest point as I go up is going to be at 3. They're both included, so I would use brackets. This time when I make an inequality notation, I'm going to use the letter y because it's representing the range. Again, since I am including these points, I'm going to use the equal sign underneath my inequality. Okay, let's look at our next problem. I'm going to look at the lowest point. So as I look to the very bottom, oh, I see those arrows again. So it's going to be a -infinity, also because it's pointing down. Right? As I look to the highest point, I notice it's going to stop right there at 4. Right? Parenthesis always for an infinity, bracket on the 4 because I could actually pass through the point there at 4. Right? If I was writing this as an inequality, I'd be using y since it's the range. I would include the equal sign underneath the 4. Now, sometimes people will omit the infinity part. So sometimes people will not include this piece to the left because it makes sense if I say that I am less than or equal to 4, obviously I'm going off to -infinity. So some people kind of think that that's redundant and they don't use it. So instead they would just have this piece that says y is less than or equal to 4, but it's definitely acceptable to write the whole thing, right? Let's look at our last example. Here we go for the range. I look for the lowest point. I notice it's going to be right here at 0. It's sitting on that axis. Okay, then I look to the highest point and I see it's going to be right there at 4. Both of those are going to have brackets because they are included. If I go to make my inequality, I'm going to put y in the middle. I'm going to include the equal sign since I am including the point. So that's how I'd find the domain and the range of a graph and of ordered pairs.